for joining me for another episode of Empower Apps. I'm your host, Dion. Today, I'm joined by Marin Todorov. Hey, Marin. Thank you so much for making the time to come on.
Hey, good morning. How are you, Leo? It's
Good,
great to be
good.
here.
Good morning for me. I don't know. What is it? Evening, I guess, probably, or afternoon.
Oh, it's an early afternoon. It's a rainy early afternoon, yeah.
Oh, well, hey, we've got one thing in common. It's raining out here, too. Uh, I am really glad to have you on. I've been wanting to have you on for a while. And with all the new stuff this year with Async and Await, I'm super excited. Before we jump in, I'll let you go ahead and introduce yourself.
Right. So my name is Marin Todorov, and I've been working on software for the Apple platforms for about, I don't know, 12 years now or so. I think I started playing with iPhone apps in 2009. And before that, I did about, I think, 10 years of web development. So it's been a long time. And I've tried like a lot of interesting things, but I gotta say, like this reactive stuff, Arc Swift and combined, and now Async Await and new changes in Swift is really like something that really clicks for me, and I really like it. And I'm really looking forward to talk more about it.
Yeah, I am a big fan of async stuff. I did a talk at 360 iDev, and I know you've got the Ray Winderlich book out. You have time lane tools, which people should definitely check out. So this is going to be quite awesome to talk about. So first, just I guess I want to get your overall reaction to the new Async Await stuff. What's your overall thoughts on it?
Right. So I think I think that there were critics a couple of years ago or so that were saying that Swift is moving relatively slowly in that whole area, relying on Grand Central Dispatch for such a long time. But I think that there was important work to be done on the language, and there was a lot of really solid improvements to do. And seeing now, like in hindsight, it just took time to build this design, right? Because there was like a few different ways that the language could have taken, and so reading through the proposals and like just playing a little bit with the new Xcode beta, I think that it's a very good approach. It's incredibly non-intrusive to your own code. It's very similar to like what you've been writing before if you haven't used reactive or so. And at the same time, it gives you all the benefits, and a new concurrency model runs all of this. So it really, like when you look at the code, it's very non-intrusive, and at the same time, it's a completely new way to like do concurrent programming. So I think it's great. Like I'm in awe. Like I've been following the proposals and the discussions, but seeing it work together is really great.
Yeah, I
What do
mean,
you
it's
think?
funny
Like,
seeing like the Chris Latner proposal from a few years ago about actors and Async Await, and like they pretty much followed through on most of that stuff. One of the things that what was I gonna say? Oh, well, so before we chatted, you're like, you got to see this video on me async sequence, I believe is the one, right? So I was watching it
yeah,
last night, and like I had done a talk on asynchronous programming and how to use combine with like core location, and like he's like showing how to adapt it, and I'm like, wait a second, I did this talk, like this is exactly like delegate pattern, how to take the delegate pattern and use it in combine. But in this case, he's like showing how to take a class with basically like closure properties, right, and adapt that to async await and with the async stream and async sequence. That seems like really powerful stuff there, that alone, and being able to create those.
Right. And sorry for cutting through, but maybe it's useful for the listeners to make a note that currently the latest beta, as we're talking, is beta 2. And so this has a sync sequence, but not an async stream,
Oh, really? I didn't
of
know
which the
that.
video is talking. No, yeah, this is not in the beta 2.
Okay.
It's in the nightly snapshot on swift.org.
Okay.
It already has a async stream, so it's gonna come in like one of the, maybe in beta 3, maybe in a later one. We don't know.
So if you're
But it is
developing on
coming.
Linux, there you go. Have at it. Because you could
Um,
just get the master and go at it.
right. Yeah. No, you can do this also in macOS.
Yeah, that's true. Yeah.
I've been doing this like in the last few weeks just to be able to like get ahead on the beta release cycle. But I play with, so So you've seen how async sequence works in that video, right? Like you have
Yeah.
the async iterator, and it's really easy to do this. And async stream is just an implementation of async sequence that gives you kind of like an any publisher kind of thing, you know? It's
Right.
just one type that you can initialize with a kind of like a worker closure, and that worker closure gets a continuation, you know, to make the async stuff work. And that
Yep.
continuation can either throw, complete, or basically yield a value.
Oh
And
yeah.
as like it's just single closure, you can just like write whatever you want inside it, and it becomes an async stream, which is an async sequence. That's it. Bam. It's really great. I'm just like completely like it's exciting because
Right. I mean, as
as
somebody who like has been doing development in like C# and JavaScript and has been using async await there, it's like it was like awesome when they brought those to those languages, and now to see that in Swift, it's like really powerful because like just dealing with closures and like all the issues that come with closures, like oh whoops, I forgot to call it in my function, or oh like I you have to make sure that you catch the throwing error and all this kind of stuff, like it's all taken care of and made sure and ensured with async await, it seems like.
yeah, a lot that the compiler does at build time for you. It's not only the type safety which you already have in with like say Arc, Swift, or Combine, but also other things like how many times do you call the continuation and things like this. So the compiler can tell, hey, you're completing 2 times the sequence. This is not allowed, and it won't compile at all. So you get a lot of safety like beforehand. Um, and what was really on my mind while we just started this is that you know, I've been talking about Swift and Combine for a while, and I worked on books and so forth. But like I feel that there was a group of people that are always willing to embrace new syntaxes and so forth, that were really excited about them. But there was also like a maybe even bigger group of people that is just not willing to, you know, change their style or coding, or like just how their project is being developed from like pure Swift, let's call it, into like something like Combine. But I feel that Async Await and the new concurrency model will help those people write safer and more asynchronous code, because it doesn't force them to change their coding style, and it doesn't force them to use a new syntax. So I think this is probably the biggest win for me in that new newly released language features, basically. Yeah.
Yeah. That's a really interesting perspective because that's true. Like a lot of people, I find a lot of people are still a little bit overwhelmed by reactive functional programming and like Combine specifically. Like, is there a reactive like methodology that you could apply to async await, or is it really more a different way of looking at things?
I think the reactive style fits very well with using async sequence and async stream, because you have exactly the same language as with the classic reactive frameworks.
Right.
With the async stream specifically, as I said, you have throwing an error, completing, or yielding a value, which is exactly the same contract that you make with Arcs or Combine. So I was just playing like really quickly because I just got back from vacation. I didn't have much time. This disclaimer. But I was just playing with this like yesterday and the day before, and I already have like a little combine operator that transforms a publisher straight into an async sequence. Just because it's like 20 lines of code, just because
Yeah.
it's the same contract. You
Right.
just need to, you know, convert from the sync into basically using the continuation in your async stream.
Well, Donnie Walls had a really good post recently about his thoughts on Combine and async await, and like one of his things was like whether like async stream or async sequence is really a good fit for like publishers and observable objects. Like, do you think Combine is a better fit for that, and then async streams? Like, I guess, would you want to go the other way around? Would you want to write 20 lines of code where you're converting an async sequence or async stream over to a publisher instead?
Right. I mean, that's also a swell idea. I mean, we can go both ways, right? Like, this really stop us. But yeah. I know it is. You know what? I think that it was in 2017 at Dot Swift in Paris where I had an Arc Swift talk, and they asked me like how much Arc Swift should we use in a project, and what I said was as little as possible. And so and so I think reactive can solve like very complex problems easily, but it could easily make easy problems very difficult to solve.
Yeah,
And
I
so I
like
think
that. That's a good
like,
analysis.
right, yeah. So I'm really looking forward to like solve all the easy problems with just like one line of async or slash await, and like still like maybe solve complex UIs or things like this with combine.
Yeah, and that makes a lot of sense because like combine, like literally in the name, it's combine. It's like you're combining multiple functions together. If you don't need that, like it's not really a good fit for like really simple stuff. I've explained that with like when people were asking like, okay, what's the difference between a promise, which is this kind of the same abstract idea behind async await, and like how like why would you use that as opposed to why would you use combine? And to me it's like if it's a one-off thing, like why would you ever use combine? That doesn't make sense. Like if you're going to make a URL request, you don't need like complex functional programming in order to do it.
Right. Yeah, I agree. I agree. You don't really don't. As I said, like if you can solve your problems easier, then you should definitely do that, and like not overcomplicate things. Plus, I mean, the new concurrency APIs that are built in the language and the kernel um, make like literally the most use of the machine that you have, right? Like, so this is why they're available in iOS 13 and macOS Monterey, because right they make the use of the special sauce in the operating system. So like literally nothing can get like better than them
So
in a way.
let's get into the one thing out of WWDC is the pitchforks and everything with async await only being supported on the latest operating systems. What like practically what do you think most developers should do if they have existing apps that like are still built using iOS 14 or Big Sur or you know one of the older operating systems?
Um, a good question. I mean, that is a very good question. I don't know. Yeah, I guess it depends. Naturally, I think that we had exactly the same situation with SwiftUI, right? Like a couple of years back,
Yeah.
and I think like currently, 2 years later, we still have two groups of developers. You know, some that have a product that has been in development for a long time. They have commitments to their customers to support previous versions and so forth. For them, probably does not make a lot of sense to use SwiftUI right now, even right now. And we have this whole other group of people who are using SwiftUI, if not like last year, then this year, and so forth. So I think it really depends on the use case.
Yeah, that's a good way of putting it. I think I would say not even Swift UI. I would say it's more like a like when they brought in Swift generics or like try catch because it's more like a language feature that you couldn't use until you updated, and like in a lot of those cases, it was just a matter of slowly updating the code over a few years to not use, you know, stupid NS error like in out pointers and stuff like that, or like NS error array in your Swift code. Like, I think it'll just happen over time. It's funny, like the expectations were like were that was that support would be there, and I think part of the problem was that like you technically could already develop using async await by using, like you said, one of the development builds before WWDC. So everybody's like assuming, you know, just get a new version of Xcode and then you could start using it right away. So it's like, then it's like it came out and people are like, wait, I need to install iOS 15 and Monterey. Whoops. Like, I think that's a big part of the expectations, I think.
Right, but But I think that this is something that probably like got lost in the in all the excitement. But I did play with the nightly snapshots from Swift.org before WWDC, and so I did some async await and actor code with the Xcode 12 and the toolchain from Swift.org, and I pushed a couple of blog posts on my blog about it as well. However, I must say that the concurrent, especially using task and especially using concurrency groups, it was extremely slow. So there is some
Slow
kind of special
like in
sauce.
execution or slow in development?
Running
Okay.
the code concurrently was very, very slow.
Okay.
And so there is some kind of special sauce that actually makes it work,
Right.
beautifully on like
That's
the
my
new kernel.
understanding. Yeah.
Yeah. And so I think this is the important part. Like the technical part is not a problem.
Mhm.
Like probably you could like use to build like a command line tool for your Mac or your Linux operating system with the like that is also backwards compatible. Its problem is that the user experience is going to be bad.
Yeah,
Right.
that's a friendly way of putting it. Yeah, exactly.
Yeah.
Yeah. And I think that's what I understood based on the form thread and all that was like there's some like you said kernel changes. At first I thought it was just that you don't have the latest version of Swift on your OS, and there's like no way of installing Swift on an iPhone, obviously, so that they use the latest version. But if there's like kernel changes in the OS, then that makes a big difference, like you said.
I I am not I didn't look at the source code, and I'm not really deep into like the implementation, but from what I've understood, like from I learned from the videos in WWDC, I watched a few times, and I read the proposals like end to end just to make sure that I'm not missing anything. But like from what I understand is that the continuation is the secret in the new
Okay.
concurrency model, in which that when you have concurrent code with ground central dispatch, the whole stack needs to be replaced on the current thread if you want to switch to a different
Got it.
application or process and so forth. And this is kind of like very slow from what I understand. While the continuation is they're comparing it with a single function call that switches the context, and so the current thread can instantly switch to a different code that it runs. And so, as I said, I'm not really into the tech like implementation details, but from what I understand is like the way that threads switch between executions is completely new, and this makes it very, very quick to switch contexts.
Yeah.
That's why you don't have, as before, explosion of threads, because each one was easier to spawn than to like switch the context of the thread. And currently you have only as many threads as cores you have, and they are utilized like to a full, because switching between contexts is very cheap now with the continuation stuff. But as I said, this is just the bird's view.
This is the gospel
disclaimer.
truth, everyone. You heard it.
Yeah. Right.
If that's not it, you're wrong. No.
Yeah. Did you have
I'm curious
time to...
now. I'm curious what it does on Linux then, right? Because like technically it would work on Linux. Like there must be some underlying code different for like there, I would assume, in order to get it working. Because it's obviously not using, well, it is using GCD, I guess. You can use GCD, sort of, I guess. I don't know. Based on the little code that I've looked at in Swift Neo, like, yeah, there's a lot of async stuff there that I'm really excited with trying out. Is like, because I'm a big server-side Swift fan, and trying out async await there and not using event loop future is going to be really nice on that end.
Oh, that's great. I'm also a big fan of Swift Neo, and and I'm also looking forward to Async Await, because even if like the framework itself is really amazing and very well designed, using all the loops is a little overwhelming sometimes. Yeah.
Yeah, event loops. Yeah, event loops and event loop future. And it's just like I'm glad it's there, but man, like, yeah. Yeah. We won't get into that. Uh, so if you're gonna start a new project with SwiftUI, I guess I kind of think we kind of answered that question. Like you'd use combine for some of the more complex stuff like observable objects and publishers and things like that. And then for the more simple code, you probably use async await, it sounds like, right?
Yeah, and I mean, I think most of the power that makes like your models work with SwiftUI is kind of like hidden behind the observable object in the like all the other property wrappers that are like kind of like by default in SwiftUI. So even though Combine powers them like behind the scenes, like you don't really have to write operators and things like this. So I think it's kind of like by default that I'm guessing first you will try async await with SwiftUI, and then eventually combine if that's really necessary.
Yeah, that makes a lot of sense. Is there anything else you wanted to talk about with async await before I jump into actors?
Yeah, I did want to mention I did want to mention that I don't want to like mislead people that this is very easy to use. Like even like we have this friendly conversation about it. Like things are still fairly complicated. Like when you wanna like you like consuming an API which is async is easy. But especially if you are providing the APIs that are async for other people to consume, that things get a little bit complicated because as I said, I've been playing around with, and especially if you ever touch Grand Central Dispatch in your code that is providing like an async API to somebody else, it gets very like half of my code was basically hanging around like being completely locked, and I couldn't really figure out like what's going on and so forth. So it looks like the transition is not entirely like is not really a walk in the park, I would say. You gotta forget like what you did before.
So is
like
it like
start anew?
Is it like the continuation stuff that's hard? Like, so I did an episode. I did an episode with Vincent, and I wrote some sample code with like creating my own task and all that stuff. Like that seemed a little bit like, and I think that's maybe what you're talking about. That seemed a little bit difficult, like being able to create like I wanted to create an async map. Okay, that's essentially what I wanted to do. I didn't care the order of the array or the sequence. I just wanted to like download a bunch of URLs simultaneously in whatever order it felt like asynchronously. And so I created like this continuation task. It's all on GitHub, whatever. Like, is that what you're talking about? Like that kind of stuff where you're actually building the async sequence, or not asyncs, like the async space sequence, or is it like other parts of creating an async API that you found difficult?
Yeah, so I ran into basically deadlocking because the new concurrency APIs don't allow you to control where your code is running, except if you're using an actor, right? Because the actor is self-contained or bound
Okay.
to the main thread. And like if you're mixing and matching, like if you have like a part of your code that is using Grand Central Dispatch that allows you to control where you run your code, and you're mixing it with like the new concurrency stuff that doesn't allow you to say, I want to consume this on that queue, as we're used to think about it.
Mm-hmm.
Like these ones like ended up being either on the same thread or like in a way that they're deadlocked and so forth. So I ran into like a whole bunch of situations like this.
Now, do you have to work with grants? Like, does the abstraction of async await still necessitate you to work with Grand Central Dispatch, or could you do any of this async await stuff without even thinking about Grand Central Dispatch anymore?
I think you should be able to do it without Grand Central Dispatch. Just the thing is that when you've relied on Grand Central Dispatch for 10 years, like this is really the first thing you do, and you're
Right.
like, oh, of course I'm gonna just like call I don't know, dispatch main queue async in now
Right.
plus 1 second.
Right.
because the first thing you want to do is like when you were, or at least the first thing I did when I was trying to test this stuff was to, have an API that waits for 2 seconds and then emits a value. And then like,
Okay.
hey, how do I wait without blocking the thread? And like this it's going to take a while. It's not really like completely, it doesn't come natural.
What were some other things you ran into that were like you had to change your frame of like thought or your the way you're thinking about it?
Yeah, it's I was trying to develop a I was trying to like convert a timer into an async sequence. And then it would just never add value. So I started to print whether I'm on the main thread or not to be able to understand whether I'm blocking myself or not, and so forth. So like I ran into this whole, we are used to think a lot about threads and cores.
Right.
Like every time I open instruments, I have the cores and like I look at the activity to see if I'm concurrent or not, and so forth. And it looks like threads are not going to be like a major player in like how we design our code anymore at all, because the whole thread management is done like it's a black box. Like we don't really have to think about this anymore at all.
Well, it seems like, I don't like, based on what I did when I was researching my talk, like it kind of the idea of like, well, even like operation queues or dispatch queues or any of that stuff has always been like an abstraction layer above like threads, and you were never supposed to like actually deal with threads manually. And that seems like this is in that same vein where it's like you don't have to think, you're not supposed to think about threads, like let the kernel, let the OS take care of it for you. And like just, don't like, kind of like the problem people have with core data, for instance, right? People do core data, they're like, well, I want to write a SQL query. It's like, no, this is an abstraction layer above like SQLite. Like you're not supposed to think about that stuff, you're supposed to let it take care of it itself. And that seems like the same case here with this async await stuff. Like you're not supposed to be creating threads manually and all that stuff, you're supposed to let it do it itself, and it knows the hardware, and like you said, it knows the number of cores and things like that.
Yeah, exactly. I think you got a great a great example there. I think the issue is that the dispatch queues, they allowed us to make them either serial or concurrent, so we kind of like automatically planned for concurrency, while
and priority.
And priority. While the new APIs are really don't giving us any of these choices anymore, because we made bad choices in the past, and so these choices were taken from us.
Typical Apple, right? So one question I guess I would have is like, we usually have control, especially when we're updating the UI, to run things in the main dispatch queue, main thread, whatever you want to call it. Is there a way to do this with async await now, so that if you want to update the UI, you can do it on the main thread?
No, there's really absolutely no control over which thread your code is running. Thankfully, there's a new main actor annotation, and that like allows you really easily to say this property should be updated, or this function should be, or this whole class should be always on the main thread.
Okay. Well, let's get into it. So this is the one thing I still haven't wrapped my head around, and that's actors. I've never dealt with actors in any language. I haven't dealt with any of that stuff. Okay, actors. Give me the 101, I guess. Or have you done anything with actors yet?
Unlike the implementation of a single waiter, so like I think I have a good grip on actors right now. So that's great news. Right. All right. So where do we start? So actors is so this is not really specifically designed for Swift. It's a paradigm that is being used in different languages and so forth. So, and it's not really specifically developed into like enabling Swift to be concurrent. It also uses like there's a lot of other use cases, and I want to touch on this a bit later. But yeah, so all in all, if you imagine a serial dispatch queue, how it works, or how it still works, is that you have pieces of work that you can schedule on it, and they will be executed one after another. And this is why a serial queue was a good way to make kind of like a piece of data thread safe or safe in general, so that when you have each piece of work being executed serially, you could never have data corruption, you could never have deadlocks, and so forth and so forth. So an actor kind of like works in a very, very similar way. And so the actor itself is serial. So when you update data from inside the actor itself, an actor is just a type. It's very similar to a class.
Right.
With some
Instead of a
limitations.
struct or a class, you have actor. It's just another
Yeah,
type.
you just replace the keyword, and then there are limitations that the compiler might tell you about. But
Okay.
it's just a kind of like a class struct actor, kind of like Trinity in there. And so it works in a very similar way as a what did I say, a dispatch queue that is serial. So from within the actor, you can just read and update your own data at will, because this is happening serially. And all the APIs of the actor that are accessible from other types, so all the public or internal types, APIs, those being properties or methods, those are inherently asynchronous, so that if another type is trying to update some of your data and you're trying to update it as well, the external API will be scheduled serially after your own access, and then it will complete. And that's why they're all asynchronous, so that because you cannot give a guarantee whether you can execute that part, this piece of
That
code,
makes sense.
synchronously or not. So everyone else who accesses your data is asynchronous, and so this allows you to execute everything else that is being scheduled to execute on your kind of like queue. And then like all of these are designed in such a way that it does not allow you to have data corruption. It does not allow you to have non-thread safe code.
Right. It's basically a fix around like race conditions where like somebody reads and writes at the same time and your values are all messed up.
Exactly, but it is done on a Swift, and it's done on a language syntax level, and so the compiler does not compile your code if you don't use it in the right way. So if you don't asynchronously update the data of an actor from outside of the actor, the code doesn't compile.
Yeah.
If you are trying to run a Grand Central Dispatch concurrent queue to create it yourself and run it from inside your actor, this is a potential concurrency issue. So the compiler does not allow you to do that either. It tells you, hey, from here you can update your data, but not create new dispatch queues. This is not allowed. And so a lot of these rules are built into the syntax and into the compiler. And so the compiler does not allow you to corrupt your data and to have non-thread safe if you use an actor.
This is really so great. Much better than semaphores, like
it
by
is.
A lot,
and
locks and all that stuff.
I know, because I've done a lot of concurrent code in Swift, and I think I have a good grasp of writing good concurrent code, and this is much better.
Yeah. Well, it goes back to the idea of like why like closures were never a great, like there were fine workaround to do async code, but like there, like we said, like there's always the chance you don't call the closure in the function because you mess something up. Whereas like with actors, it sounds like this is all compile time, which is one of the strengths of Swift is how like strong typed it is, and like makes sure that you do things correctly, as opposed to like a Objective-C or a JavaScript where things are much more dynamic. So like this sounds like a big improvement in that case, and that's going to be really nice. So is it actor type basically is it a reference type, like a class underneath?
It is a reference type.
Okay.
Yeah.
But with that thread safety, I guess, so to speak, on top of it. Okay. Yeah. That makes a lot of sense. And it makes sense about the await, why everything is async, because like you said, everything has to be scheduled properly so that no two things are run at the same time.
Yeah. So there is a chance that your call goes synchronously, but there is no guarantee for it. So you kind of like always need to await on APIs being executed. And I think all of the material so far, all the content so far about actors, it always talks about the concurrency and so forth. But actually, actors are about isolation of functionality. And so you can imagine that between your actor and everything else, there's a barrier, which automatically, does async communication. And this is very interesting because, if you don't make any assumptions of what's going on inside the actor, and if you don't make assumptions of like when is the code gonna execute, how long it's gonna take, and so forth, this leaves the actor like a lot of freedom. And so it could be, for example, if you have an actor that you give it an ID, and then it gives you back some kind of an object from a database or so. What are the assumptions of the actor? Like, is it reading a local file like on your device, or is it like shooting out a URL request to your server and like reading something back, or is it like a mesh of computers in a network and like they need to mine Bitcoin to get you the answer or whatever? It doesn't matter. Like, you really have no idea what the actor is doing. Can be like completely. And the best thing is since you don't make all of these assumptions, like you can have like a run configuration that when run with this configuration, your app like uses an actor to read data from disk, and then just another command line can like replace and use a different actor that reads from network and so forth. So like there's a lot of like there's a gigantic plethora of possibilities where this could go. Like it really opens up a lot of opportunities.
Yeah. Do you think like there's any specific use case where you'd see somebody say, you'd tell someone, hey, like this needs to be an actor, whatever you've been doing before, this needs to be an actor now, as soon as you can?
Right. So I think it should probably just happen also automatically. Like if you have any code that use locks, these are probably like obsolete.
Or semaphores. Same idea.
Yeah, semaphores. Yeah, exactly. Especially if you've been using a lock to lock around like data access, this is completely. Or if you had like this was a pattern, I think in the last few years that it was recommended to use dispatch queues to make data concurrency safe. And so if you use dispatch queues to make a piece of data, thread safe, or if you use locks for this, completely.
Like when I've been playing around with like, I love doing like taking sequences and being able to run through them asynchronously. And like the one case would be like, how do you create an array that would be asynchronous? And like, I'd have to have a lock in order to make sure that if like some process is done and it actually writes to the array, that it makes sure that two things don't write to the array at the same time. And like that was a classic case of where like an actor would make sense, is that you want to make sure that if there is a process that's writing to the array, that it does it like without like running into thread safety issues. So yeah, I get where you're coming from now.
Yeah. I think it's a great addition to the language, and as I said, I think it's great that you can just go on the internet and like read about actors in different languages and like read white papers and things like this, and have a much bigger understanding and a lot of the big picture of what this could mean for Swift.
So one of the questions I wanted to ask you was like, with all this thread stuff that we've added, you're a big fan of instruments, I would assume. What are some things? What are some things, recommendations you'd make if you're going to run your app through instruments to make sure that you're using this stuff in the most optimal fashion, I guess?
Right. Here I think there's a problem because the current instruments or instrument to profile like threads and so is designed, I think, with Grand Central Dispatch in mind.
Okay.
And so I'm not completely sure like how useful it is going to be right away for Async Await code. So previously we had like, you would see like a whole list of threads that your app is creating, and then you will see how many at a time are busy and how busy they are and so forth. And I think this is still valuable to detect like how concurrent you are. But I think currently we would be more interested in like how many times you yield or when you can like use continuations. And I can't even imagine it right now, to be honest. I think I didn't see anything about Async Await in instruments this year. So I think we all need like a year to think it through, and probably in the next year we'll get something specific about Async Await.
Yeah, like you have, obviously you're the author of Timelane, which is a big app in that space. I was just looking at your how should profiling new Swift. I was looking at that GitHub issue.
Yeah.
And I had some like interesting thoughts there about how to abstract that away and make it visual. I would assume though you still need some updates to instruments before you can really take advantage of it, and that might be like obviously not till next year where they have a good grasp of how async await is being used, right?
Yeah, I'm not so sure if Timeline could provide something useful this year. Although, as I was saying in the beginning of the conversation, it's the contract, like the possible events that can happen, is exactly the same as with reactive frameworks. So I'm assuming that like we could have some simple addition to timeline that helps you figure out when you yield values, or when you start incomplete groups, things like this. But I still didn't have time to play with it. And as I said, since there was no additions to instrument this year, I don't think we can really make like something amazing like before we have instruments like give us more. Yeah. But I'll certainly try. Like I do have in mind, like to play around.
Try. That's what every developer says.
Yeah.
Yeah. Is there anything else you want to talk about with async await?
I think that not specifically. I think that the actors
or combine, I guess.
Yeah, I think that the actors are really great. At least to me, they feel like a very a new concept in the language that really would open a lot of possibilities. I would like to recommend like whoever is listening just not to think about them in this one thing that does data isolation in a concurrent code, but like think of like what else could be done when you cannot make an assumption about the implementation of an API that I'm consuming.
Yeah, that makes a lot of sense. Well, before we end, I wanted to ask you about a certain project you've been working on this year that was revealed at WWDC.
Oh, yay.
Do you want to talk about what was the big feature that was revealed, and what's your overall thoughts about it?
Sure thing. So for the listeners that don't know, I did contract for Apple for a while, and the team I was on for a while, as I said, worked on a new feature inside Xcode called Doxy. So Doxy in Xcode is a documentation compiler that sees the structure of your framework and extracts all the comments that you have in code and source code, and builds like this complete Apple-style documentation out of your framework with all the links, with all the sections, with all the navigation around it and so forth. It allows you to see it inside Xcode's documentation viewer alongside your Apple frameworks, and also it allows you to export it as a web archive that you could put on a Apache server, for example, or Ruby on Rails, what have you, and also serve it on the web. And the interesting spin around it is because you do have like similar tools to do that, but as I said, the interesting spin about it is that you can use Markdown, and also you can use Markdown to write articles, to write this like kind of like intermittent pages that kind of like group your documentation into topics, or what would you call them?
Well, there's like tutorials,
tracks, or so. And
yeah, there's a lot there.
And you can also build like this interactive tutorials that you've probably seen on SwiftUI or building iOS apps, Mac Catalyst, and so forth. So there's a whole lot to unpack there. I think that people are just, literally just starting to explore what
Yes.
Doxy can do. Yeah.
Yeah, I
Uh,
am really excited about this. Like, I'm really looking forward to deep diving into it. Full disclosure, I've not had a lot of time to deep dive into it because I don't get to open Xcode Beta 13 a lot, busy as I am. But yeah, this is something I'm super interested in. I'm curious to try it out and get some of my open source projects over to Doxy. So I'm kudos to you and your team for building this. This looks awesome.
oh yeah, this is something that we missed to mention for whoever did not watch the sessions. Is in one of the sessions it was announced that Doxy is going to be open source as well.
Yeah.
And so, I think this is really exciting because not only you can build Apple-like documentation, but like you can have a look at the source and decide to do something else as well if you want to.
Now, can you host these? Like, I'm probably asking a question that's been asked by 1,000 people, but I'm going to ask it anyway, and you can answer if you want to. But can you host these pages like on GitHub pages or like Netlify pretty easily? Because I know there's some like rewrite rules you have to write in order to get it working. I don't know if that stuff works on those services.
Right. So the session about hosting the exported documentation highlights the steps to do that on Apache, but I guess that like on another server like Node.js or so would be pretty easy as well. Like it's literally just a few lines of code. I'm not so sure if it works right away on GitHub Pages or Netlify.
Okay.
I think I saw that a bunch of people are already looking into this.
I'm sure they are. Yeah. Who?
I think Paul Hudson had a tweet about working on like a static HTML version of the archiver. So
yeah, there's I tweeted about that too recently. Helgi has a. I hope I said his name right. I chat with him all the time, but he has like a GitHub project about static site generation for Doxy, and I think that's awesome. Like, especially if it goes open source, we're going to see like a big explosion in that area, and like getting all that stuff working out with CI is just going to be fantastic.
Oh yeah, I mean, right now people are just like playing around with like what's there in Xcode, but like once things are open source, you can't really. You're not really bound by like the binary. You can just have a look at what's going on inside and decide to do it differently.
Yeah. Is there anything else you wanted to mention before we close out?
No. I'm really glad that we got to talk about Doxy as well. Like I'm really excited, and I'm just happy that it's out. And it's been some time that it's been in development. It's really great to see it out there.
Yeah, I bet. So two things I wanted to mention before we close out. This is episode 98. So again, audience members, if you have any questions for episode 100, reach out to me. I have an email address, episode100@brightdigit.com. So you can send your questions there or send them on Twitter, whatever. I'm looking forward to that. I also wanted to address a certain question that I've been teasing about. So I got access to Xcode Cloud, and I can't get it to work. So that's the answer to that question. I started a brand new, so I don't know if I'm doing something wrong, but I also, like I said, I don't have a lot of time right now, but I started a brand new Xcode project, and then I go in and create the workflow, like tap. Do you have access? If you can you tell me?
Who, me? No, I don't have access to Xcode.
So I created a new Xcode project, and I tapped create workflow, and Xcode crashed. And like, I don't have the time to like go in and like tinker around. It's a brand new Xcode 13 project, so it's not like I'm like trying to update an old project or anything. So I'm like, that's where things are at. So maybe in the next episode, I'll see if I can figure it out. Of course I filed a feedback, but that's where things are at there. So sorry if I built that up, but nothing really I could do at this point.
Oh, no.
So yeah, that's it. Marin, thank you so much for coming on the show. I really appreciate it. It's great to have you on and talk Async Await. This has been fantastic.
Yeah, it was a pleasure. I'm really like positive about these new APIs, and I'm really happy to talk about them as well. And I really hope to like know a lot more about the things that we talked about. I'm really curious how it happens, like in the implementation side and so forth. So I'm really looking forward to like having a better grip of that as well.
Yeah, me too. Links to Marin, his website under Or is it?
Underplot?
Yes, underplot.com. His book, his Ray Winderlich book on Combine and time lane tools, links are in the show notes there. And how do I pronounce your Twitter handle?
I can Zilb.
Okay, there you go. He's on Twitter as well. Any other links I forgot to mention?
No, that's great. That's pretty much what I'm up to right now. I have this like super little app which is on my website as well called Ambience. When people are curious about like what I've been thinking with lately, they can just go there and give it a try.
Awesome. Thank you again for coming on the show.
Thank you.
People can find me on Twitter at LeoGDion. My company is Bright Digit. You can go to brightdigit.com or on Twitter at brightdigit. If you could take some time to fill out the survey for the podcast, link is in the show notes. I'd really appreciate that. And also take some time to post a review, subscribe, or like if you're watching this on YouTube. Also post a review to Google Podcast, Apple Podcast, wherever you're listening. Thank you so much for joining me for this episode, and I look forward to talking to you again. Bye.
Sure, bye.